Now today we are going to discuss about regression after the discussion of correlation coefficient, which we discussed in the previous video. Regression is also a statistical measure which calculates the strength of relationship between two and more than two variables. There is a simple regression analysis in which we use two variables. One must be an independent variable and another one must be dependent variable. As you are seeing here, that one variable is income and another variable is consumption. In this question, consumption is dependent variable and income is an independent variable. So it is the case of simple regression analysis in which we use two variables, whereas in multiple regression the number of variables may be 3, 4, 5 and infinite based on your strength of effort. In multiple regression analysis, the variables may be more than 2. But in case of multiple regression, one very important thing you should keep in your mind, and that is you can take only one dependent variable and number of independent variables may be more than 2. So the conclusion is that in regression analysis the number of dependent variable must be 1, either in case of simple regression or in case of multiple regression. So now we are going to discuss or calculate the simple regression analysis. So here are two variables, as I discussed before, that income is an independent variable and consumption is dependent variable here. So just like as we discussed in the previous video of correlation coefficient, that we need only the calculation of 5 different type of variables. For example, one is X, that is income, and one is Y, that is consumption. So dependent variable is also always denoted by Y. So these extra 3 calculations which we use in our final calculation, and one is the product of XY, another one is X square, and the third one is Y square. So now we have in fact two different methods to calculate regression analysis. Equation of regression analysis is equals to y hat is equals to alpha plus beta x. It is the case in which we discuss that y depends on x. So another case, you can reverse this analysis. This equation x hat equals to c plus dy mean second variable depends on first variable depends on second variable. So these are two different options, but mostly y hat is equals to alpha plus beta x is calculated in majority of cases. So as we know that y is dependent variable and x is an independent variable, so we want to say y hat equal to alpha plus beta x means y variable depends on x variable. So there are a lot of methods to calculate regression analysis or to do regression analysis, but we use here two different methods. One is the method through correlation coefficient. So first of all we calculate correlation coefficient, which I discussed in the previous video. Same calculation is done here. So formula for correlation coefficient is sum of xy divided by n minus mean of x multiplied by mean of y and whole divided by standard deviation of x and standard deviation of y. So sum of xy is 45183 divided by 10. 10 is the count. There are 10 values, so 10 is count minus it is mean of x. Sum of x divided by n is always equals to mean of x variable, and sum of y over n is equals to mean of y variable. So sum of x is 668 and sum of y is 676 and whole divided by standard deviation of x and standard deviation of y. So here we calculated standard deviation of x and standard deviation of y. So standard deviation of x is 2.75 and standard deviation of y is equals to 1.624. Formulas are given. If you want to see the formula once again, here are formulas: standard deviation of x and standard deviation of y. So after putting all the values, we get here correlation coefficient is equals to 2.62 divided by 4.466, and finally the answer is 0.5866. So it indicates that there is a positive relationship between these two variables, but how much positive, it will be seen here after the regression analysis. So correlation coefficient only defines the relationship, not mostly the strength of relationship. So if we want to see the strength of relationship, that how much positive is, so here is the first method. If we calculate x hat equals to c plus dy, this relationship is only given for you to understand the calculation of x variable depends. If x variable depends on y variable, then we can use this equation. But normally, as I said earlier, that normally y variable depends on x variable, but it is the reverse case, only given for your knowledge. So here regression equation of x on y is equals to x minus x bar is equals to beta x on y multiplied by y minus y bar. It is very easy to understand or remember that if you want to calculate x on y, x variable depends on y variable, then x minus x bar you should place to the left of the equation, and y minus y bar to the right of the equation. So here we need beta x on y. So what is the beta x on y? X depends on y. So beta is regression coefficient. So according to the formula of correlation analysis, it is always equals to correlation coefficient multiplied by standard deviation of x and standard deviation of y. So after putting the values, correlation coefficient is 0.5866 and standard deviation of x is 2.75, we calculated above, and standard deviation of y is 1.624. So after putting the values, we can get the answer 0.9932. So now we are going to calculate the regression equation, which is, in the case of x depends on y, it is equals to x hat equals to c plus dy. So x minus x bar is 66.8 equals to beta x on y, which is 0.9932 multiplied by y minus y bar, and that is the mean of y variable. So after the calculation of whole equation, we can get the value 0.9932y minus 0.34032. This value without the variable is c and 0.9932, which is with the variable, is dy. So after arranging these two in the equation form, x hat equals to c plus dy means x hat equals to 0 minus 0.34032 plus 0.9932y. This means that if there is an increase of 1 unit in the variable of y, it will result to increase the variable x for 0.9932 units. So in the reverse case, regression equation y on x, it means that y variable depends on x variable. So same logic will be applied here, that we place y minus y bar here and equals to beta y on x and x minus x bar to the right side of the equation. So after putting the values, now one calculation more which we need here, that is beta y on x, and that is equals to r, or correlation coefficient, multiplied by standard deviation of y divided by standard deviation of x. So after putting the values in the equation, we can get the answer 0.3360. So after putting the values here, final result is 45.1552 plus 0.3360x. It means that if there is an increase of 1 unit in the variable x, it will result to increase y by 0.3360 unit. Here one another method which I recommend to you, that is easier than this method, and that method, if we calculate the beta y on x, or simply if we want to calculate y hat equals to a plus bx, means y variable depends on x variable, so we just simply use this formula. According to this formula, beta y on x is equals to summation xy minus n x bar y bar divided by sum of x square minus n x bar whole square. So after putting the values in this formula, the answer is 0.3465. So as you see here, that in the previous method beta y on x is 0.3360, which is very close to this another method. So in my point of view, this method is more easier than this method. So same, what about alpha? Alpha is equals to y bar minus beta x bar. So y bar is 67.6 minus beta is 0.3465 multiplied by 66.8, and alpha will be 44.45. So in this previous method, we calculate here the alpha 45.1552, which is very close to this method. So after putting the values in the equation, 44.45 plus 0.3465x, so the result is same. If we want to calculate x hat equals to c plus dy, then we just little bit change in this formula. For example, beta x on y, we just change There is a little bit problem, so just wait for a while. Now, so beta x on y, only we change x with y. Here in beta y on x, it is equals to sum of x square, but in beta x on y, it will become sum of y square. So similarly, we just replace x with y, and that will be beta x on y. I want to add something more to clarify you. Now it is right. So that will be the formula for beta x on y. And similarly, we will change the formula for alpha. This y bar will become x bar. And this y bar will, x bar will become y bar. So now here you can use this another formula, but I said earlier that normally y variable depends on x variable. So normal case is discussed here, and if you want to use this formula, in this case normal analysis is here. So now after the calculation of regression analysis, it is asked in the question that find the value of y when x is 80. It means that if income is 80, which is not given here, what should be the value of y? So it is very important and interesting calculation of regression analysis that you, after the calculation of regression equation, you can calculate the value which is not given in the data, or if you don't have the value. So find the value of y when x is 80. So here this is our regression equation. So simply we just put the value of x here, and after the calculation of whole equation we can find the value of y. So after putting this value into the equation, final value is 72.0352. Thank you.